Hello, welcome. I'm Martin Loetzsch. I work at Project A Ventures in Berlin. There are my slides. So Project A Ventures is a company builder based in Berlin. And I'm working there in a team that builds data warehouses for the ventures of Project A. And today I'm going to talk about how we do that. And before I do that, talk about this, I will make some totally unscientific claims about the typical startup. And the typical startup has data in some application databases, the backend. It has Excel files, CSV files, and all sorts of external tools that somebody found useful to install. And typically what you have then is some Excel or Google Docs-based reporting tool chains where people run some queries of the backend database and copy and paste stuff from other data sources. And well, this works really well, and I think this is how many or maybe most companies operate. This is often difficult to debug and test, and also Excel gets cranky occasionally with, as soon as your data that you have exceeds a certain amount of volume. Another problem with this is that everybody then in this company pulls their own numbers. So one guy just counts the rows in a database, for example, the order table. Another guy is smart enough to exclude the test orders. But if you ask a third person in the company, he will then do something more sophisticated and check only consider only the orders that were paid. And this is, of course, not nice if everybody comes with their own numbers. And it gets even more difficult if you have things like profits or cost and so on, where there are conscious decisions to be made how to process and integrate data. The typical startup also does not have big data. So many people scare you into, oh, you have to invest in big data technologies. If your database is only 1 gigabyte big, or even only 1 terabyte, then you don't have big data. And also, the typical startup will not have big data in the relevant future. And with relevant future, I mean the next month, or the next half year, or the next year, or any time frame where you should spend time on having data quick and having numbers in a way that you can grow your business. And of course, the goal of your company should be to be big enough that you have big data. But in order to do that, don't focus on the big data yet. Also in the previous talk, we heard that if you do a company, one really key challenge is to have numbers about your business. And whoever you talk to, everybody will tell you, do some kind of data integration, have numbers that are in a central place where there is a single point of truth, so there is only one way to compute number of orders or revenue and so on, where this data is cleaned up and validated, where test orders are excluded, and where there are clear semantics of how to process this kind of data, where the data is easy to access. That means that you can easily hook on your Excel or your product recommendation engine and so whatever, and that is embedded in the organization so that everybody in the company knows and uses this data to make data-driven decisions. And, well, this thing is typically called a data warehouse, which I think is a really bad name, but that's what it is. So you take a bunch of data from all your systems, and then you have it, and then you can use that for reporting, for marketing control, for sending emails, for tuning your search, for pricing, and. So you have all the things that your company knows about their customers, about their behavior, about their operations, and then can use it for something useful. And so it's not only about collecting orders and counting them and so on, but it's also about establishing relations between data from different domains. For example, to have orders and their users, and then clicks and products, and histories of prices and stocks, and data about emails that were sent, and so on. And of course, all of them you can measure separately in the systems that produce that data, but there is a genuine value in integrating these data. For example, to have your complete clickstream correlated with your users, that you know for each user what were the marketing contact points before his acquisition, how much cost did he have after his acquisition, and so on. So to do something which you cannot do in Google Analytics or in your application database, because both don't have the other data. And well, the question is then how to build this, or how to get there. And a typical way that many companies then do is to go of one of these big data warehouse business intelligence vendors like IBM Cognos or SAP Business Objects or MicroStrategy, and well, ask them to help you. You cannot do this yourself, so I tried 2 weeks installing SAP Business Objects on a computer. I failed, although I think I have some knowledge in installing stuff. And this is because this is a classic agency business where you then ask an agency to build a warehouse for you, and which typically takes then also forever in startup time. So you cannot wait for a year for this to finish, or if they didn't finish, your startup in the meantime already does something else. And it's also too expensive normally, so nobody has this 1 million euro upfront just to count orders. Another way would be to use one of these cloud-based, like automatic data warehouse solution where you upload your data and they do something. That's fine. So I think that's already much, much better than these big vendors that install stuff in your basement. But there the problem is that your startup is different from every other startup, and then you very soon will have this business question that you cannot answer with the way they model data and represent it, and because it's usually not possible to extend them. And what I will going to try to convince you today is to do this on yourself, by your own, because it's very easy. And at Project A Ventures, we do that. So we are also in the fortunate situation that we are a company builder, so we can reuse stuff we do at each of our ventures. But I think it's also worthwhile if you are a single company. And this all is possible with technology that existed already in the 90s. So you don't need something fancy new. It's really boring, simple scripts that run inside a database. We use then something called Pentao from Mondian, which is an open source analytics engine. I will show that later. And our own lightweight reporting front end. And so for us, this whole thing is integrated in the back end of our shop system. So Project A has its own shop system called EvenZ. And well, this integration then also makes integration with other processes in the IT infrastructure easier. So I will show all this in this talk. And but my general suggestion or advice would be to do the most simple thing you can imagine and to keep it pragmatic and easy. And also don't use a Hadoop cluster if you don't have terabytes of data. So now we'll get kind of really trivial, or really, you would say, okay, why is he doing that? So the basis of a data warehouse is a so-called fact table. And here we have our little pet store, where that's so far sold 6 pets. And you see it's cats, dogs, and cows. And so each of these sold items has an order item ID, and it has an order ID, and there is some price, and the thing happened on a day, and, well, there was a product. And so what I would try, whatever you do, is to bring data from different domains in such kind of fact tables. Because if you have this kind of representation, they are super easy to query. For example, you can ask what were the orders all time, and you go through the order ID column and this thing counted. Or you can ask what was the revenue on October the 1st, so then you sum up the price column where the date is the 1st of October. Or you can ask, like, so per product, what was my sales? And there you would count the IDs of the items and group them by product. So you see this is really fairly simple operations. And in fact, if you restrict yourself to only aggregations, filtering and grouping, then you can do very powerful and amazing things with that. So aggregations are really simple things like sums, count, distinct count, average over columns. So like the number of sold items would be just a count on an item ID column. Or the number of orders would be a distinct count on the order ID. Or the revenue would be the sum of a price. Or the average product price would be the average on the same column. And if you manage to get your data in this kind of representation, then you can easily already take this and put it into Excel. Excel is really good at pivoting data, but you can also use SQL front ends like a ClickView or a Tableau. You can, if you really have terabytes of this, then put it into Elasticsearch. Elasticsearch is really good at filtering, grouping, and role aggregation. Or you can use it with Mondrian. That's what I'm going to show you later. Or, in fact, any other BI front end that you want to build. So try to get your data in this kind of form, where KPIs are simple aggregations. Then you might find out that this is maybe not the super most efficient way to store data. So you will then probably start reading books. So this is a book I recommend. It's really boring, but or it has also really difficult jargon. But what this book will tell you to move some of the stuff to dimension tables, for example, to make a day table and a product table, and add foreign keys to these tables from the fact table. So in the lower left, you see this dimensional schema. This is basically to make things more efficient and faster. And so if you start doing this, read this book. So after a while, this will look like this. This is from a venture we just started, Controyon. So there are basically mainly only fact tables and dimensions about sales. So also if you read these books, there will be a lot of debate about whether to use a star schema or a galaxy schema. Or some people will say, oh, you should use second normal form or third normal form. My advice would be to ignore all of this. So the people are really opinionated there, and do whatever you think it is fastest for the use case that you have. This is from a project which we are currently more or less wrapping up. This is about sending money, and this is one project we exited in August, where there's a really rich domain of topics that is modeled in this thing. Fine. So we have data in our data warehouse, and now the question is, how do we get the data in there? This is the first question. And this is called data integration, or sometimes it's also called ETL, which stands for extract, transform, load. And so what most people do is they use a visual ETL tool where you where you have some kind of visual programming paradigm to create your data processing pipelines. And the advantage of that is that you get many things for free, like connectors to all sorts of data sources. My advice would be to not use them, because they are, so if then something goes wrong, then it's really hard to debug. And they are also slow to change. So if you have one more column in your dimensional schema and you need to also load stuff more from the data, then you have to click through all these boxes again in order to change something. And that's why I would recommend to start with very simple SQL queries and batch scripts. And it can be as easy as writing an SQL file that creates some tables and piping it into Postgres, or then piping a query into MySQL and piping then the result of that query into Postgres, or to cut some CSV file to some Python script that filters some columns and then pipe the result into Postgres, and then run a query in Postgres that does something with this. And so this is super easy, this is super fast, so there is no Java programs involved in running this. And it's easy to understand, easy to change, and yeah. Later, the advice would be to build something more robust. So at Project A, we basically still have the spirit of batch scripts, but we have it with a graphical user interface. So I will show this. Unfortunately, my computer just died, so I'm not on my own, so I'll show it on a live system. And no. Oh no. Like this. No. I know what, I will just skip this. So the idea is to have, can we see this again? To have basically processes that do something, that in the beginning load orders and then transform them, and that load all sorts of other things. What you see here is something we call jobs, and a job is basically just a list of commands that that runs in a sequence. So this would be one job that is specified in an SQL, in an XML file, where it says like, okay, first run this file, then run this query, and then add an index in the end. And this is super developer friendly because, well, you see everything. It's easy to put in a Git branch. It's easy to do QA and so on. So this is what we do. So then once you have all this data in your data warehouse, how do you get reports out of it or queries? And there's a very nice thing that was developed by Microsoft in the 90s that's called MDX. And as part of it was developed as part of their analysis services. And well, you don't often hear computer scientists praising Microsoft for something, but this thing they got really done really well. So instead of having like select some columns from some tables, you have the idea of selecting dimensions and measures, and then doing all sorts of tricks that you also would do in Excel with these dimensions and measures. For example, here you have a query where you take some measures and the descendants of some products from some cube and cross-join that and then on the columns, on the rows, and have the time on the month. And you would get such a nice table that computes your, that shows the result from the fact table we've seen before. Or you could say, give me the top 2 products and the revenue for that for October. That would be the other query. So, right, so you write kind of semantic queries. And also the nice thing is that each KPI that you show or compute is always computed in the same way. And so then we use a thing called Mondrian, which is a query processor that can process MDX, and it's an open source project. It's part of the Pentao BI platform. So BI platform, this is also something where you would also have an ETL tool and dashboards and so on. We recommend not using that, but using only this. And I also recommend reading this book. So this is really nice about how to do BI cubes and how to do reporting and so on. It's in Java, has a very active community, and in general is a really nice thing. So how does Mondrian execute these queries, these MDX queries? Well, it knows about the structure of your dimensional schema because you tell it. So you write an XML file like this where you say, okay, I have a date dimension and a product dimension, and these are the tables where they are, and here are the columns where I can define some levels. And I also will tell you how you get from the fact table to these dimension tables by specifying the foreign keys. So essentially, it's kind of the picture you see at the top right, kind of written down in XML file with descriptions and names. And then you also have your KPIs, where you can say, okay, the number of orders is, again, the distinct count on the order ID column, and as displayed as a normal number, or the revenue is the sum of the price column. And the nice thing is also you have these calculated members, where you can say, okay, the average cart value is the revenue divided by the number of orders. And what Mondrian is then doing, it creates SQL queries. So it gets an MDX query, like the one on the bottom left, the months on the columns, and the average cart value on the rows. Then it looks it up and is mapping how to compute these values, creates an SQL query like this, runs it against the SQL database, and returns the result. Yeah, so another advantage of having the complete definition of your KPIs and dimensions in one XML file is that you, first of all, you can draw it, and my recommendation also would be to always draw these relations between KPIs and to document the definitions of your KPIs and your dimensions, because then everybody in the organization can look up what exactly is the contribution margin to be, because even the people who build it will not remember after 10 weeks how it's computed. Yeah. So we have this Mondrian engine. It can execute MDX queries. And so, but how do you actually then really see numbers? And one thing we always give our ventures is something called Saiku. That's also an open source project that talks to Mondrian via MDX. And I will just quickly show you the demo they have on their website. Where do I make an ad? Here. So here you have some sales cubes. So this is an example database that's very often used in these data warehouse communities. And you would have here some KPIs, and then maybe some product families. Right, and so what you can do is you can kind of, in a drag and drop fashion, put dimensions and KPIs in this kind of thing here, and then play with it. You can filter. You can say, I want to have this only for food, or I want to have the store also there for the preferred country, and so on. So this is a really nice tool to explore data. So we give this to our companies so that they can play around with that kind of data. But also, once they are once they happen to do the same query very often, we then also have something where we have a fixed set of reports in our backend, and this is some lightweight HTML code with Bootstrap and Google Charts. It lacks many features, but on the other hand, so maybe also very fast in implementing features. So the numbers you see here are completely randomized, because it's actually very difficult to show data warehouses live. So here's an example of a report where you basically have around one typical business questions. Have tables and charts, and yeah. unfortunately, my computer died, so otherwise I would have demoed this. So how does this front end talk to Mondrian? And this happens with another kind of protocol, which is called XMLA, was also developed by Microsoft. And it's basically, you can send a SOAP request to some XMLA server with the query, and then you get back some result, which is, again, some XML. It's a bit difficult to read, but I think you will very quickly be able to process this data and make some visualizations out of it. So to summarize this, we have all kinds of data in files and databases and so on. We do some data integration inside our backend. The stuff ends up in a PostgreSQL database. Then we have Mondrian issuing SQL queries to the database. We have the Saiku talking via MDX to Mondrian. And we have our reporting that talks to this Mondrian thing via this XMLA thing. And so putting together this XMLA server and Saiku can be a bit difficult, just in terms of getting the Maven thing right. And that's why we open sourced it. It's called Monsai because it's Mondrian and Saiku in a single, easy to configure WAR file. So it's on GitHub. So far, it's only README because we didn't finish it for the code.talks, but will happen the next weeks. And so some final 2 remarks. This is very important that we deal with it all the time because we not only have to do this, but we also have to find people in our ventures that pick up this work and to continue. And so this is, on the right, you see a job ad that we are very successful with in hiring people. And what we don't look for BI experts, because they are typically like people who studied economics and then learned Excel and VBA, and then started also drawing database schemas. So these people you don't want to have around your database. And that's why your ideal candidate is a normal computer scientist that knows about software and is some kind of full stack engineer. So it's in the slides that will be online later. So we are very successful with this ad. And the last thing is, so if you do this, do a normal software development process. So where you have product managers and developers. And in fact, because business intelligence is so, let's say, product heavy, we have as many product managers as we have developers in our teams. So there is some kind of parity. Well, and the product managers, they basically draw these pictures. And then developers, they build these pictures. And there is a lot of talking in between. And so we do this with some kind of mixture of Scrum and Kanban, but I think any of these kind of processes works. But the recommendation would be to do that because people like me, I'm a computer scientist, I really don't care about how to compute profits or I really don't care about the business questions. On the other hand, people who do care, they don't know about how to get these things fast and smooth. Yes, and I think that was my last slide. Thank you very much for listening. If you have to remember one thing, then this, please.
Gibt es Fragen?
Hi, do you think Elasticsearch could be a database to use instead of Postgre?
Yes, I do think, and I said also a recommendation of mine would to be that if you do have terabytes of data that don't fit on a single machine anymore. I don't think, so even if you have terabytes of data, I think Postgres would still be a good database for doing all these ETL and transformation, because it has a very rich, well, SQL language to manipulate data, which you will not have in Elasticsearch. And so many people nowadays say, okay, there's all this old school SQL, but on the other hand, it's really, really great to get things done. And so Elasticsearch I would only use for querying. So if you have really terabytes of data, and when you need to filter, to group, and to aggregate, and this is what it's very good at. It's not good at integrating data.
Okay.
So in fact, there are many people who do this with click streams, where like each document would be one click with lots of dimensions, and well, then you can easily aggregate and count, and so on.
How do you deal with the typical business requirement? I want every question answered by the data warehouse that will ever came to my mind.
Well, we typically ignore that. So in this well, product management process, so as soon as you have some kind of data warehouse going and people recognize in the company, oh, cool, there are people who have numbers, everybody will jump on them and say, oh, I also want this. And so that's why I also said make it a normal software development process where then these ideas are collected and then later on prioritized by business. And then the lesser good ideas will be implemented later or never. Okay, if there's no more questions, then thank you again. Yeah. All right.